Okay guys, today I am going to tell you how to solve KCL. So what is KCL? KCL is basically Kirchhoffs current law. So it is a law presented by Kirchhoff. So Kirchhoff said the sum of the current entering the node and sum of the current leaving the node will be same. So if one current is entering here, the current will pass through this node. So we will say that current of I1 will be equal to I2. So that is Kirchhoff's law. And what about this? When we subtract I1 with I2, we will left with 0. So the Kirchhoff says the sum of the current entering or leaving the node is equal to 0. So from this, let me tell you how to solve a question by this. So first of all, let us take a circuit. So the circuit I am going to take is, we have this voltage source of 12 volts. After that we have this branch, and after that another branch and another branch, and that's it. So we have 12 volts and we have 1 kilo ohm of resistance here, 6 kilo ohms of resistance here, and 3 kilo ohms of resistance here. So now we have to see the direction of the currents. So by conventional current, it will be originated from this plus sign. So the plus current will come here in this loop. So let me name it. It is I1, and after that when it comes to here, it will divide into two other currents. So this current is entering the node. So this is current entering the node, and the both currents are leaving the node. Let us say the current is I2 or I3. So first we have to see which current is entering the node and which current is leaving the node. So one current is entering the node and the other currents are leaving the node. From this we can have our equation of KCL. So if I draw the arrow at here, so the thumb is that I have to see what's on the tail. On the tail it is 12 volts, and on the head I don't know what the voltage at here, and this whole thing is grounded. So here is 0. The whole this area belongs to this. So now I am calculating this current. So this current is entering the node here, and this current is leaving as well as this current. So the current which is entering the node, I name it I1, and the other two I2 and I3. So I1 is entering the node and I2 plus I3 is leaving the node. The current entering the node will be here at the left hand side, and I am writing the current leaving the node at right hand side. So from here I1 is what? So in case of I1 you have to see what at its tail. So at its tail it is 12. So you have to write 12 minus what is at its arrowhead. It is V0. So V0 divided by 1 kilo ohms of resistance. And what about I2? I2 is V0 at its tail. It is V0 minus what is at its head? It is 0 divided by the resistance here is 6 kilo ohms, plus what is I3? I3 is V0 minus 0 divided by 3k, because at its tail it is V0 and at its head it is 0 and divided by resistance. So current is equal to V over R. So now I have to calculate this V0. In order to calculate this V0, I have to simplify this equation. 12 minus V0 divided by 1k equals V0 divided by 6k plus V0 divided by 3k. So after this I have to take it as common, and V0 plus 2 V0 equals 3 V0 by 3 kilo ohms of resistance and 6 3 2. So I will left with V0 over 2k, and at here I have 12 minus V0 by 1k. This k will be cancelled out with this k, and I will be left with 12 minus V0 equal V naught by 2. So from here I have to bring this V naught to here, then 12 equals V naught by 2 plus V naught. So taking 2 and V naught plus 2 V naught 12, 3 V naught by 2 equals 12, 24, the 2 go in here and 4, and V naught will be 24 over 3. 3 8 are 24. So the V naught will be here, so the V naught will be 8. So from this I know how to calculate the voltage at this node, which is 8 volts. So this is a KCL, and you now know how to solve this equation, and you have to know how to draw this current signs. First you have to see that current is entering the node and the other currents are leaving the node, so you have to write it as this. So by this you can have your equation of KCL, and by KCL you will get to know the voltage at the nodes. And after getting voltage at the node, you can calculate the current and whatever you want. So if I want to calculate the voltage at this resistor, so what will I gonna do in order to calculate the resistance? So V naught here was 8 volts. So let me write here 8 volts. I have already written that. So in order to calculate the voltage at this one, so we have to do 12 minus 8 equal voltage at 1 kilo. 4 equal voltage at 1 kilo. So the voltage drop here will be 4 volts. And after that, if you want to calculate voltage at this level, we have 8 minus 0. 8 minus 0 equal voltage at 6 ohm of resistance. Then we will have V6 to be 8 volts. And similarly, so we don't have voltage source at this point, so this point is already 0. Then we will having 8 voltage at this branch and 8 voltage at this branch. But at this branch we will not having 8 volts, we will have 4 volts. So from this you can calculate the voltage. So in order to calculate the current, you just have to do is V equals IR, then V equals IR. The voltage at this point was 4 volts, and you want to calculate the current, the resistor is 1 kilo. Then I will be 4 by 1 kilo, then I will be 4 divided by, it will be 4 milliamps. So from this you can easily calculate the current at this point. So what about the current at 6 kilo ohm resistor? Again you have to do V equals IR. The voltage at this point is 8 equals I, what is R? 6 kilo, and I equals 8 by 6. 4 are 8, 3 are 6. So the current will be here. After calculating it, you can know how to calculate the current at this point. Similarly, you can calculate the current on that point. So in this way, you will be calculating the current in this direction, the current in this direction, and the current in this direction. So I hope you will know how to calculate the KCL on this example. So if you like this video, please don't forget to subscribe, give this video a big thumbs up. See you next time.